Hello everyone, welcome to the physics class, and today we are going to solve the MCQs of chapter number 2. Last time we already solved the MCQs of chapter number 1. So see this MCQ number 1. In this figure below, what is the equivalent capacitance between point A and B? The figure is given. 3 capacitors are connected in this manner, and what is the equivalent capacitance between A and B? So in series combination of capacitor, the equivalent capacitance is 1 by C1 plus 1 by C2 plus up to 1 by Cn, and in parallel combination it will be C1 plus C2 plus up to Cn, right? So in this connection, identify the connection is series or parallel. See this capacitor, the both terminal of this capacitor are shorted by this wire. Whenever you short the both terminal of any component, then there is no effect produced by that component. So ignore this capacitor from this circuit because both the ends of this capacitor are shorted. So only 2 capacitors are connected here. So both these are in parallel, so equivalent is C plus C, so that is equal to 2C. Question number 2. In the beginning, the space between the plate of the parallel plate capacitor containing air, and thereafter it is filled with a medium of dielectric constant K, then what happen? So यहाँ पर dielectric insertion की 2 मेथड होती है. In first method, connect capacitor with a battery. Then after charging of capacitor, remove this battery. Means suppose Q charge is present here, plus Q and minus Q. Now remove the battery and insert a dielectric constant between 2 plates. Then what happen? Then the capacitance becomes K times. Charge remain same as initial. No change in the charge. And the potential becomes 1 by K times, and the electric field becomes 1 by K times, and the energy also becomes 1 by K times. So you should remember which quantity is changed and which quantity remain constant, right? How this potential difference becomes 1 by K? So potential C is equal to what? Q by V. So V is equal to Q by C. Now the charge is Q, final charge, and capacitor becomes Ck, so this becomes 1 by K. Now if you connect a battery with a capacitor and charge it, and at the time of insertion of dielectric the battery remain connected, then what happen? Then capacitance becomes K times, charge also becomes K times, potential difference between 2 plates remain as it is, electric field also remain as it is, and the energy in the capacitor becomes K times. Energy is equal to Q square by 2C. So new charge Q square K square by 2CK, so 1K cancel, it becomes K times. So you should remember this table. This is most important table, right? At the time of insertion, the battery is connected or not connected. The quantity depends on that condition. So whenever nothing is given, battery is connected or not connected, you should consider the first case when battery is removed after the charging of capacitor. Then what happen? See the option. The electric field and capacitance becomes K times. Electric field is not becomes K times. The first is incorrect. Second, the electric field becomes 1 by K times and the capacitance becomes K times. That is correct. So B option is correct. See the option number C. The electric field becomes K times. That is incorrect. The electric field and capacitance becomes 1 by K times. That is also incorrect. So B is our answer for this question number 2. Right. Now check this question number 3. 3 identical capacitors are joined in parallel and charged with a battery of 10 volt. three capacitors are connected in parallel and charged with battery of 10 volt. So potential difference between two plates of all capacitors becomes equal, and that is equal to 10 volt. Now the battery is removed and they are joined in series with each other. Now they are joined in series with each other. Here 10 volt, here 10 volt, here 10 volt, then capacitance C. In this condition, what would be the potential difference between the free plate in this combination? Free plate means which is not connected to any other plate. So this plate is free and this plate is also free. So what is the potential difference between these two plates? So that is equal to 10 plus 10 plus 10, that is equal to 30 volt. Question number 4. If the volume of earth is V and surface area of earth is A and its capacitance will be, the capacitance of spherical capacitor is equal to 4 pi epsilon naught r. Earth is also sphere, so find the radius. So volume of sphere is 4 by 3 pi r cube and surface area of sphere is 4 pi r square. So it becomes 4 pi cancel, r square by 3, r by 3. V by A is equal to what? R by 3. So R is equal to 3 times V by A. R is equal to 3 times V by A. So capacitance is equal to 4 pi epsilon naught and R is equal to 3 times V by A. So that is equal to 12 pi epsilon naught V by A. So our answer is D. D is our answer. This fifth one is most important question. 27 small drops of water having same charge and same radius are combined. Suppose the charge on this drop is Q and radius is R. Combined to form a bigger drop. 27 drops are combined to become a bigger drop. Let us assume that the radius is capital R for this drop. Then the ratio of capacitance of one big drop to small drop is, capacitance of drop is equal to what? So capacitance of drop is equal to, drop is spherical, so capacitance is 4 pi epsilon naught r. So capacitance is proportional to radius. The volume of bigger drop is equal to the 27 times volume of small drop. And volume of drop is 4 by 3 pi r cube. 27 into volume of small drop is 4 by 3 pi small r cube. 4 by 3 pi cancel. So r cube is equal to 27 r cube. So take cube root. So r is equal to 3r. So the capacitance C dash by C is equal to r by r. So r is equal to 3r by r. So that is equal to C. So C dash is equal to 3C. Capacitance become 3 times. This is the capacitance of bigger drop and this is small drop. This is the radius of bigger drop. This is the radius of small drop. So capacitance becomes 3 times. The ratio of capacitance big drop to small drop is 3:1. B is the answer. If suppose in this question they ask the potential on this first sphere, first drop, small drop, and if they ask the ratio of potential of bigger drop to small drop, then what? Then what is the answer? Now potential is equal to KQ by R. Potential is equal to KQ by R. Now the charge on this bigger sphere is equal to 27 times charge of small sphere, because small drop has charge Q. So you combine 27 drops, then the charge on this bigger drop becomes 27 times Q. Then this potential is proportional to Q by R. Now the ratio of bigger drop by small drop, potential of bigger drop by small drop is equal to charge on bigger drop, the radius of bigger drop, into charge on small drop divided by radius of small drop. Charge is equal to 27 Q and radius is equal to 3R into Q. R cancel, Q cancel, 9 is answer. 9-1 is answer. For the ratio of bigger drop to the smaller drop, potential on bigger drop to the smaller drop. So these both questions are important. Sixth question. The capacitance of variable capacitor joined with battery of 100 volt charge changed from 2 microfarad to 10 microfarad. What is the change in its energy stored in it? The energy stored in capacitor is half Cv square, or you can say Q square by 2C, or you can say QV by 2. But here capacitance and potential difference is given, so use this formula. So change in energy is equal to half final energy minus initial. The potential difference is constant V, only capacitance is changing, so half Cf V square minus half Ci V square. So take half V square common, Cf minus Ci, half V square, potential difference is 100, so 10 power 2 square, 10 power 4. Final capacitance is 10 microfarad. 10 microfarad minus 2 microfarad means 8 microfarad. So this is equal to 4 into 10 power minus 2. So 4 into 10 power minus 2 joule is the answer. So D is our answer. Seventh question. The dipole moment of dipole is, dipole moment P is equal to 4 into 10 power minus 9 coulomb meter. The potential of a point away from 0.2 meter means R is equal to, R distance of point is 0.2 meter. The direction making an angle 60 degree with the axis of dipole is, potential due to dipole is Kp cos theta by R square. So K 9 into 10 power 9, P 4 into 10 power minus 9 cos 60 divided by R square, 0.2 square, 0.04. You can write this as 10 into 2 into 10 power minus 1. So 2 square 4 into 10 power minus 2. 4 4 cancel. 9 into cos 60 1 by 2. 10 power 9 minus 9 0 and 10 power, take 10 power 2 in numerator, that is equal to 10 power plus 2. So 9 by 2 is 4.5 into 10 power 2 volt. 4.5 into 10 power 2 volt. So 450 volt is our answer. Question number 8. 10 microcoulomb charge is placed on the vertex of equilateral triangle of 10 centimeter side. Same charge is placed on all vertex, that is equal to 10 microcoulomb of side length 10 centimeter. Electric potential energy of this system. To calculate potential energy, make a pair of these charges. Potential energy of pair of these charges, make a pair of 1 with 2 and 1 with 3. Now make a pair of 2. 2 is already paired with 1, so make pair with 3 only. So potential energy of charge Q is equal to KQ square divided by KQ1 Q2. QQ is equal to Q square by distance between them 10 centimeter plus between 1 and 3 KQQ Q square by 10 centimeter. Between 2 and system of charges 2 and 3 KQQ Q square by distance between them 10 centimeter. So this is equal to 3 times KQ square by 10 centimeter. So 3 into 9 into 10 power 9 Q square, charge is 10 microcoulomb. So 10 micro means 10 power minus 5 coulomb. So 10 power minus 5 square, 10 power minus 10 and 10 into 10 power minus 2. So that is equal to 9 3s are 27 into 10 power minus 1 plus minus 1 minus 1 minus 1 plus 1 means 0. 27 joule is the answer. So revise the concept of potential energy. Potential energy of system of charges. Whenever you are writing potential energy of system of charges, then make a pair of all charges. Potential energy of two charge is equal to K Q1 Q2 by R. So now make a pair of charge Q1 with 2, so that is equal to U12 make a pair of charge q1 with 3, u1 3, and make a pair of 2 with 3. So add all this term, then you will get the answer of potential energy of system of charges. Now next topic is potential energy of system of charges in external field. Then what happen? Suppose already electric field is present here, then you are taking these charges from infinity to here, then what is the potential energy of this system? So first make pairs of this all charges, that is equal to u12 plus u13 plus u23, then add some extra term. The potential energy of charge E1 due to this electric field is charge q1, and potential at this point due to electric field is VR1. Add second term, charge q2 and potential due to this electric field at this point q2. Charge q3 and potential due to this electric field at this point is VR3. So add all terms and you will get the answer of total charge, total energy of this system. And our another topic is potential energy of dipole. Potential energy of dipole. So whenever you keep a dipole in electric field, then what happen? The potential energy of dipole is equal to minus P dot E, and the torque acting on dipole is P cross E. Now whenever the angle between P and E is equal to 0 degree, then what happen? The energy becomes minus PE cos 0. Cos 0 means 1, so that is minus P. So this energy is minimum, and the torque acting on it is equal to PE sin 0. Sin 0 is 0, so torque is 0. So torque is 0 means this dipole is in equilibrium and energy is minimum, so it is in stable equilibrium. So this case is called stable equilibrium condition. So whenever the stable equilibrium of dipole is given, then consider the angle between P and E is equal to what? 0 degree. The second one, whenever the theta is equal to pi, 180 degree, then what happened? The energy is equal to minus P cos pi. Cos pi is equal to minus 1, so it becomes plus P, that is equal to maximum energy. And the torque acting on dipole is PE sin pi. Sin pi is equal to what? 0, so torque is 0. Torque is 0, so it is in equilibrium, but the energy is maximum, so that is called unstable equilibrium. So this is the unstable equilibrium state of dipole in external electric field, whenever the angle between P and E is pi degree, right? So whenever stable equilibrium or unstable, you can say that this is most stable or this is most unstable. These terms are given, then you should consider the angle between P and E is equal to theta 0 and pi. Now work done in rotating dipole is equal to change in potential energy, that is equal to final energy minus initial energy. So final energy is equal to minus P cos theta f, and initial energy is equal to minus P, so minus minus plus PE cos theta I. Take this P term common, then it becomes cos theta I minus cos theta f. So whenever the question is given that what is the work done in rotating dipole from stable equilibrium to unstable equilibrium. Stable equilibrium means dipole is in stable equilibrium, means theta is equal to 0 degree, and you are taking it in unstable equilibrium, so theta is equal to pi. Then what happened? What is the total work? So PE cos theta is equal to 0 and theta f is equal to pi. So PE cos 1 minus minus 1 minus minus plus 1, so 2 PE is the work done in rotating dipole from stable equilibrium to unstable equilibrium. This topic is most important for the exam, you should remember this topic. Then the next question, ninth, the electric potential due to electric dipole varies as the electric potential due to single charge is proportional to 1 by r, and potential due to dipole is inversely proportional to r square. You should remember. So for dipole it is inversely proportional to r square. Now our next question, question number 10. Electric field on the surface of two spheres of radius r1 and r2 are same. Then the ratio of their electric potential will be. If the electric field on both the surface of sphere are same, then kq by r1 square and kq by r2 square. kq1 by r1 square and kq2 by r2 square is same. So q1 by q2, that is equal to r1 square by r2 square. Then ratio of the electric potential. So v1 by v2 is equal to what? K q1 by r1 divided by k q2 by r2. So k cancel, q1 by r1 is equal to r2 into r2 by q2. So q1 by q2 into r2 by r1. So q1 by q2 is equal to what? q1 square r1 square by r2 square into r2 by r1. So r1 by r2 is our answer for ratio of potential. 11th, for a uniform electric field E0 I cap, so electric field is in x direction. The electric potential at x is equal to 0. V0 is equal to 0. The value of electric potential at x is equal to x will be. The potential difference, to derive the potential difference, you should remember the relation between electric field and electric potential, that is equal to minus dV by dx. You can write that whole relation like this: del V by del x I cap plus del V by del y j cap plus del V by del z k cap. So whenever only electric field is in only x direction, then use this relation minus dV by dx I cap. So electric field is given E0 I cap, that is equal to minus dV by dx I cap. So I cap cancel, that is equal to minus dV by dx. Magnitude is also same. So from this, dV is equal to minus E0 dx. Now integrate both side, dV minus E0 dx. E0 is constant, take. We are finding potential from 0 to x, and at 0 the potential is 0 and at x the potential is V. So integration of dV is V, so V minus 0, and integration of dx is x, so x minus 0. So potential V is equal to minus E naught into x is our answer. So B is our answer. Potential at plus x is equal to minus E naught x. Sometimes different questions, they are also asking a different type of question. Consider another question. If in a region potential is 2xy plus 3y square z plus 5x square z, then find magnitude of force acting on 1 coulomb charge at 111. This is question. Now whenever the potential, equation of potential is given, use this formula to derive the electric field from that potential equation. So differentiate this equation with respect to x first, then what happen? So 2x, so 2y is constant, differentiation of x is 1. 3yz, there is no x, so this is constant term, so differentiation with respect to x is 0. 5z is constant, then differentiation of x square is equal to 2x into I cap. Now differentiate with respect to y, so 2x is constant, differentiation of y is 1. 3z is constant, differentiation of y square is 2y plus no y is present, so differentiation with respect to y is 0 j cap. Now differentiate with respect to z, there is no z, so differentiation is 0. Z is present, so 3y square is constant and differentiation of z is 1, and x is present, z is present, so 5x square is constant and differentiation of z is 1 k cap. Now we have to find the electric field at 111 point. 111 point means what? X is equal to also 1, y is equal to also 1, and z is equal to 1. So this is equal to 2 into 1 2, 5 into 10, 1 into 1 1 I cap, 2 into 1 2, 3 into 2 is 6, 1 into 1 1 j cap, 3 into 1 3, 5 into 1 5 k cap. So that is equal to minus 12 I cap plus 8 j cap plus 8 k cap. So this is the formula of electric field at this point 111. Then what is the magnitude of electric field? That is equal to under root Ex square plus Ey square. 12 square 144, 8 square 64, 8 square 64. So this is equal to 4 4 4 12, 6 12, 6 plus 4 10, 10 plus 6 16 plus 1 17. So 1 plus 1 2, root 272 is magnitude of electric field at point 111. So force acting on charge at that point is equal to Q into E. So charge is 1 coulomb and for electric field is root 272. So root 272 Newton is our answer. So sometimes this type of question also they ask. Sometimes they ask only electric field, so calculate up to this only. Next question 12. 2 coulomb charge is displaced from a point of potential minus 20 volt to other point. The work done is 200 joule. The electric potential of second point is, the work done in moving charge is equal to Q delta V. So Q delta V is final potential minus initial. So work done is 200 joule, Q is 2 coulomb, V2 is V2 and V1 is minus 20, so minus minus plus 20. So 100 is equal to V2 plus 20. So V2 is equal to 80 volt. V2 is equal to 80 volt. The dimensional formula of capacitance. Capacitance C is equal to what? Q by V. So what is the formula of potential? I into R. I is equal to Q by T into resistance. R is equal to, or you can write formula of potential, volt. Volt is equal to joule per coulomb. Joule per coulomb. So that is equal to charge of unit of coulomb, charge is also coulomb. So coulomb square by joule. Joule is equal to kg meter per second square. So formula is m minus 1 L minus 1 T2 and Q2. So answer is B. B is our answer. In a electric field is prevailing in a x direction in certain region, the coordinate of PQR is given. Electric field is in x direction and the coordinate of P is 0 0, so P is here. Q is 2 0, so that is here, and R is 0 2, so that is on y axis. Which of the following alternatives is true for the potential at this point? Remember that whenever you go in the direction of electric field, then potential difference will decrease. So whenever you shift to right side in the positive x direction, the potential will decrease. So both this point P and Q are at same place for x axis. X coordinate of both point are same 0 0. So potential at both point are same. And whenever you go in the direction of electric, the potential will decrease. So potential at Q is less than this P and Q. So this is our right answer. So that option is Vp is greater than Vq and Vp is equal to Vr. A is our answer only. Option A is our answer. So remember that sometimes it is given electric field is in this direction, and these are the 3 points. So what is the relation between potential at this point? So whenever you go right side, the potential will decrease. So maximum potential is at A, then at B the potential is less than A, and at C the potential is less than B. So this is the relation between A, B, C. Whenever the points are on the same line, means another point D is on same line, then potential at A and B also same, because this become equipotential surface. So remember this topic also, equipotential surface. Equipotential surface means what? The potential, the surface on which the potential on every point, potential at every point is same. So for point charges, the equipotential surfaces are spheres. For parallel electric field lines, the equipotential surfaces are the plane passing through the electric field and perpendicular to that electric field. These planes are equipotential surfaces. For dipole, the equipotential surfaces are like this, and for the pair of two equal charges, equipotential surfaces are like this. So you should remember these figures for your exam. And remember one most important point, equipotential surface is always perpendicular to the electric field. So electric field is always normal to equipotential surface. And remember, the work done in moving charge between 2 points on equipotential surface is always 0, because the potential is same at the both points on equipotential surfaces. So work done is equal to Q delta V. Potential is same, so potential difference is 0, so work done is also 0. Next question, question number 15. An electric dipole moment P is dipole of dipole moment P is placed parallel to the uniform electric field of intensity E. On rotating it through 180 degree, the amount of work done. Work done is equal to, we already discussed, PE cos theta I minus cos theta F. You are rotating dipole from 0 degree to 180 degree. Then work done is PE cos 0 minus cos 180. Cos 0 is 1 and cos 180 is minus 1, so minus minus plus 1. So answer is 2 PE. On the axis, on the equator, on the axis and on the equator of electric dipole, for all points on the axis, the potential due to dipole is Kp cos theta by r square, and theta is the angle between axis of dipole and the point, position vector of point P. The angle between P, dipole moment P, and the position vector r is theta. Whenever the point on axis, then the theta between the angle between P and r is 0. Potential is 0, theta is 0, then the potential becomes Kp by r square. On equator, the angle between r, on equator, the angle between r and P is 90 degree. And the potential becomes 0 because cos 90 is 0. So option on the axis V is not 0 and equator V is 0. So D is our answer. D is our answer. 17. Three capacitors 2, 3, 4 are connected in parallel. Then what is the total capacitance? 1 by C in parallel, add all the capacitance. So 2 plus 3 plus 4, that is equal to 5 plus 4, 9 picofarad. A is answer. Question number 18. Equipotential surface through a point is normal to the electric field at that point. अभी मैंने आपको बताया कि ऑलवेज इलेक्ट्रिक फील्ड इज नॉर्मल टू द इक्विपोटेंशियल सरफेस, सो इक्विपोटेंशियल सरफेस इज ऑल्सो नॉर्मल टू द इलेक्ट्रिक फील्ड at any point, right? So normal is the answer.